Today, lesson 13B, systems and constraints. Last lesson, we talked about how to graph a system of inequalities. Today, we take that to word problems, and in some sense, it's similar to the way we attack systems of equations. We dealt with 3 different methods, and then we did 5 days worth of word problems. Well, today we follow up systems of linear inequalities with word problems that involve systems of inequalities. So let's go ahead and get started. First of all, a constraint is a limitation or a restriction, and I know that that definition is already in your notes. So let's go ahead and get started with number 1. Number 1, it says, on a table there are 20 coins. Some of the coins are quarters and some are dimes. Their total value is at least $3.05. Find 4 combinations of coins that satisfy the problem. So we basically have several limitations here. One of them is that there are 20 coins, exactly 20 coins. And then the other one is that the total value is at least $3.05. At least $3.05 means, if you didn't realize it, $3.05 or more. So here's what I want you to do. I don't want you to try and set up a system of inequalities. I just want you to do some guessing and checking, and I want you to find 4 combinations of coins that satisfy this. So 4 combinations of coins where we have 20 coins and where the total value is $3.05. And I guess the other thing is we need to make sure that we're only using quarters and dimes. So I'm going to give you a couple of minutes to come up with 4 combinations of coins that satisfy this problem. So here are some combinations that satisfy this. 7 quarters, 13 dimes, that's $3.05. 8 quarters and 12 dimes, that's $3.20, and so on. So the idea here is that there are lots of combinations that will satisfy the problem. And what we're going to end up doing after a couple of problems here is we're going to try and figure out a way where we could find this sort of thing a little faster without some sort of guess and check method, which is really what we were doing on this one. All right, let's go to number 2. Number 2 says Tom's company needs to hire at least 20 workers. So there's constraint number 1, at least 20 workers. So 20 or more workers. Some of them are working in Factory 1 for $1,000 per month, while others are working in Factory 2 for $1,200 per month. The total salary of all the workers should be at most $30,000. So that means $30,000 or less. Find 3 combinations of workers that satisfy the problem. So I want you to do this one in a similar way to the one that the way that you dealt with number 1. Okay? We have several constraints there. Find 3 combinations of workers. So you have some workers at Factory 1, some workers at Factory 2. We know we have to have at least 20 workers, and we have to have at most $30,000. I'll give you a few minutes to try and figure that out. Okay, so there are lots of combinations that will satisfy the problem. I came up with 10 at each one. And remember, it could be more than 20. It just has to be at least 20. 10 of each would make $23,000, and we're trying to make at most $30,000. So then I did 15 at Factory 1 and 5 at Factory 2. That was $21,000. And then 1 at Factory 1 and 19 at Factory 2, and that's $23,800. But like I mentioned after the previous problem, there must be a faster way of figuring out some of these combinations without some sort of guess and check method. And that's the idea of what we're doing today. So we're going to now take a look at number 2 in much the same way that we dealt with this kind of problem yesterday. And we're still on the front side of your notes. We're going to now go to the coordinate plane that's there. So what we want to do is we want to set up a system of inequalities that will satisfy this problem. So I'm going to state that X represents the number of workers in Factory 1. I define my variables every single word problem that we do. And I'm going to say that Y represents the number of workers in Factory number 2. And one of the reasons why that's important here is because if I don't have any labels on my x-axis and y-axis, that helps me determine what those look like. And so your coordinate plane looks like this. And so notice that I used x plus y is greater than or equal to 20 for my first inequality. And that comes from that very first sentence. Tom needs to hire at least 20 workers. We have some workers at factory 1. We have some workers at factory 2. I don't know how many are at each of them, but I know we need at least 20 workers, which is greater than or equal to 20. My second inequality comes from the fact that factory 1 workers make $1,000 per month and factory 2 make $1,200 per month, and then the total value is at most $30,000. Now what we want to do is we want to graph this system on that coordinate plane. Now this brings me to another situation here, and that is this. We typically, most of you anyway, typically like to put all of your equations and all of your inequalities in slope-intercept form. But we've talked about another method of graphing other than slope-intercept form, and that's using the x-intercept and the y-intercept. So let's try graphing each of these using the intercepts. So if I graph x plus y is greater than or equal to 20 with the intercepts, anybody know what the x-intercept is? Just say it. What is it?
20.
It's 20. What's the y-intercept?
20.
It's 20. All right, so let's plot both of those. The x-intercept is 20, and the y-intercept is 20. So that's represented by the blue dots that are there. This, of course, is a solid line. So use your ruler to connect those together. And now the question is, since this is a linear inequality, we have to decide which side to shade. And I have always said that if 0, 0 is available, that's the easiest point to use. So does 0, 0 make a true statement in that first inequality? Yes or no? No, it does not. So we're going to shade the other side. Now we're going to take a look at the second inequality. And once again, I'm going to go with the x-intercept and the y-intercept. So here's what I want all of you to do right now. I want you to, I'll give you about a minute, I want you to, for that second inequality, to figure out what the x-intercept is and what the y-intercept is. Go ahead and do that very quickly. All right, so we came up with an x-intercept of 30, so I plotted it on the x-axis. We came up with a y-intercept of 25. I plotted that on the y-axis. Another solid line here. Now, we need to test an ordered pair to see which half plane I need to shade in. And if I use 0, 0 there, it does make a true statement this time, so that means I shade on the side where 0, 0 is. All right, so now we have this nice graph here. What in the world does the graph mean in terms of this problem right here? Peter?
The middle color, I don't know what color that is. It shows us the number of workers in either factory. Like let's say you could have 20 in factory 1 and 1 in factory 2. So all of the answers in the red, I think that fit in the equation.
Yeah, so what you're saying basically is that every single ordered pair inside of this region right here, every single ordered pair in that region will be a combination that will satisfy this problem when we're comparing the number of workers in factory 1 and in factory 2. So you gave us 20 in factory 1 and 1 in factory 2. 20 in factory 1, 2 in factory 2. 20 in factory 1, 3 in factory 2, and so on. So every single ordered pair in there will give us a combination of workers that will satisfy this problem. Because every single ordered pair in that region is a solution to this system. All right, so let's go to number 3. And let's first of all start by me having you set up the system of inequalities that you think will work, and then I'd like you to stop right there because I don't want you to graph it if you have the incorrect system. So let's just start by you reading the problem and coming up with the system that you think will work for this problem. System should look something like this. I'm using x and y. X plus y is greater than or equal to 15. Some of you went p plus m is greater than or equal to 15. And then the second one, 10x plus 6y is less than or equal to 120. All of them have to be represented by minutes. Now, go ahead and graph that system. And then we're going to try and come up with 3 combinations that will work. So if I graph the first one using the intercepts, it looks like this. If I use 0, 0, that does not make a true statement. In the second one, I'll use the intercepts one more time. And I will use 0, 0, and it does make a true statement. Therefore, the overlap is in this area right here. So, I mentioned that some of you had something that looked kind of reverse from this. The only thing that I can figure out is that you used X for math and Y for physics, but we're going to find out right now. So one of the things I wanted you to do was to give me 3 possible combinations of things that will work here. So Prince, give me one combination that you think works. Okay, hold on. 6 for the math, 16 for math, and how many for physics? 2. All right, so does that work? 2, 16 is right there. So that does work. All right? Georgia, give me one combination that you think works. What's that again? 3, 15. So 3 of the physics and 15 of the math? Yes? All right, 3, 15 is right there. That's actually right on the line. So that still works. Okay? Another one that works. Yes? 1, 17. So 1 of the physics, 17 of the math. 1, 17 is right there. So that happens to work as well. So anywhere inside of that triangular region right there, any ordered pair in there will be a solution to the system. Therefore, it has to be a combination that will work. Are there any questions with number 3? All right, so we're going to do the same thing with number 4. Do it all the way through, and then we'll compare what we have with our shoulder partner, and I want you to come up with 3 combinations that will satisfy what we're looking for here. I'll give you about 5 minutes. First of all, system of inequalities, and I'm defining my variables right here, but based on those, here is the system that I would use. I know some of you use different variables, and that is fine. The graph, once again, I'm going to go with the intercepts, and if I plug 0, 0 in to that inequality, the first one, it does make a true statement. Second inequality, using the intercepts, 0, 0 does make a true statement. So every single ordered pair inside of that region right there will make a true statement. Therefore, that's a combination that will work. I asked you to find 3 combinations. My favorite one was 0 hours of video games and 0 hours of bowling. Yeah, that will work. It's kind of a cheap way out, but it satisfies the system. But just make sure that any ordered pair that you used will work within that region right there. Okay? All right, we are finished.